Hi there, it's Mrs. Tellas. We're going to talk about scientific notation and using or operations with scientific notation. So here we go. This is also in section 6.1. So scientific notation is written as a number, we're going to call it A, times 10 to some power. We'll call the power n. A couple things, that A number, that front number has to be in the range between 1.0 and 9.9 repeating. So there's only one digit in front of the decimal at all times, and it can't be a zero. And then the N can be a positive number or a negative number. So if I take 12 million and I write that in scientific notation, I would take those non-zero numbers in the front, 1.2, and multiply that by 10. So I want to put the decimal here, and currently it's in the back. So I'm going to count up 1, 2, 3, 4, 5, 6, 7. So since it's a big number, 12 million is a huge number, I'm going to make that a positive 7. Had it been a really small number, like smaller than 1, I would make it a negative 7. So since this number, 0.0000987, is smaller than 1, actually way smaller than 1, it's a very small number, I would put my 9.87 first, times 10, and then I count over to here. 1, 2, 3, 4, 5. So it's 5 jumps, so I put a 5, and this is a tiny number. It's not even a penny, so it's going to be a negative 5. So if I do the same thing, but I go backwards, standard form is just a regular number. So 3.04, I write that down. I'm jumping over 7 times, and I'm making the number bigger, which means I'm moving the decimal to the right side. 1, 2, 3, 4, 5, 6, 7. And in these little spaces go zeros. Oh, too many. Yeah, there we go. And then I can put my commas in. So 30,400,000, because I added 5 zeros. And on this one, I'm doing the 6.8 and I'm going left. So 1, 2, 3, 4, 5. So that's 4 zeros and the 68. And I knew I was making it smaller because of that negative right there. So I knew I was moving the decimal to the left-hand side. So we're going to skip this stuff. All right, least to greatest. There's one of these on your worksheet. So if the numbers are all in scientific notation, means they're between 1 and 9.9 repeating. They're all in scientific notation. So since they are, I look at the exponents to decide. So least to greatest, my smallest would be the 6. So that's my first one. 8 would be my second, 9 would be my third, and 10 would be my fourth. So if they're in scientific notation, the exponent tells the stories. Now, these look like they're in scientific notation, and the first one is because this is between 1 and 9.9. But 430 is not between 1 and 9.9 repeating. So since it's not, I'm going to go ahead and change all of them, and neither is that one and neither is that one, to standard form, and then just compare the regular numbers rather than comparing in scientific notation, since most of them are not written correctly. So 5.3 to the 6th power means I'm making it bigger, and I'm jumping 6 times. 1, 2, 3, 4, 5, 6. So I'm doing a 53 with 5 zeros. So 5,300,000. And then here, I'm making this smaller by 1. So I'm going over 1. This is 43. Here I'm making it smaller by 2. So that's 52. And here I'm getting the 45, making it bigger by 5. 1, 2, 3, 4, 5. So a 45 with 5 zeros. So like that. So you can tell based on the regular numbers that we know how to look at, that this is my first one, the least. That's my second. This would be my third, and my last one would be, this one, the 5,300,000. So if you can't tell from here, you got to put them in regular form or standard form, and then you can tell from there which one's smallest to largest. All right, so now we're going to start the operations with the scientific notation. So if I have 3 on the outside, I'm going to multiply 3 times 4.5. You're definitely going to want a calculator here. So 3 times 4.5 is 13.5. That back part is just going to come over. It's going to slide over to the right. So then I look at it and I ask myself, is this front number between 1 and 9.9 repeating? Well, it's not. It's bigger than the range it's allowed to be in. If it was a number line, it would be over here somewhere, 13.5. So I have to change just this part to scientific notation. So I'm going to move the decimal over by 1. And this is how I tell whether this is a 1 or a negative 1. If this 13.5 is bigger than the range it's allowed to be, it's a positive 1, which it is. Then I just pull the other part down. And then my power to a power, or actually my multiplying like bases, this is actually why this is in the section. So I would just add the exponents. So 1.35 times 10 to the negative 6 is my final answer. Same thing here. I'm going to multiply. 0 0.6 times 7.8, and I'm just typing it into the calculator. And that part just came straight down. And then I assess whether or not this is okay. And 4.68 is between 1.0 and 9.9 repeating. So that's the answer. I don't have to adjust it. I'm good. All right. So number 7 is multiplying numbers in situation or in scientific notation. So what I do here is I multiply my A's, my front numbers. So 2 times 7 is 14. And then I multiply my like bases, which means that I have to copy the base and I have to add the exponents. So I copied the base already, and 3 plus negative 8 is negative 5. And then I have to look to see if I need to adjust. 14 is bigger than the range it's allowed to be in, so I change it to 1.4 times 10 to the first. I went with the first power because I moved it one spot, and it was bigger than the range it's allowed to be in, so it's positive. So then I combine these two. 1.4 times 10 to the negative 4 is my final answer. So let's try number 8. If you want to stop and try it on your own, that's a really good idea. Best pause and give it a try and then turn it back on, see if you did it right. So 5 times 6 is 30, and 10 to the 6 times 10 to the negative 12 is 10 to the negative 6. But 30 is too big. It's way bigger than 19 or 9.9 repeating, so I'm changing it to 3.0. And since it's bigger, I'm making it to 10 to the first. And then I'm combining these two. So 3.0 times 10 to the negative 5 is the answer. Number 9, if I multiply 2 times 3.8, that would just be 7.6. And I'm just adding the 7 and the 5 together. And this is perfectly fine. 7.6 is in the right range. All right, so this is power to a power. And I know that because what this means is 4 times 10, 4 times 10, 4 times 10, 4 times 10, and 4 times 10. So there's 5 of them. But that's okay to do it when there's 5 of them. But what if it's 4 times 10 to the second, all raised to the 25th power? Whew, that would be a lot to write down. So instead of doing it this way, I'm going to use my power to a power rules. Remember, I write down the base. This is an exponent of 1, and I multiply 1 times 5. And I write down the base, and I multiply 2 times 5. And then I'm going to use my calculator for 4 to the 5th power. So that's 1,024. And then I look to see if this is in proper scientific notation, and it's way too big. It's supposed to be between 1 and 9.9 repeating, and it's not. So I'm going to change it. So 1.024, remember one digit in front, times 10. Now I jumped over 3 spots, and this was quite a bit bigger than my range, so it's a positive 3. And then I'm just combining those two. So this is times 10 to the 13. So that's my answer. So for the negative 2 one, if you'd like to press pause and try it, that's a good idea. If you just want to watch me do it, that's okay too. 6.25 is got an exponent of 1. I copy the base and I multiply 1 times negative 2. I copy the base and I multiply and get 24. So I'm just going to put this in my calculator. Normally, I don't want decimals, but on scientific notation, I totally do want decimals, no fractions. So that gives me 0.0256 times 10 to the 24th. This is way too small. The smallest it's supposed to be is 1.0. So when I move it over, I move it over 2 spots. And since I moved it 2 spots, it's a 2. And since it was smaller than the range, I make it negative. So now I'm going to combine those two. So 2.56 times 10 to the 22nd is my answer. All right, and then the last skill we have here is dividing numbers in scientific notation. So we do this very much like the multiply, except we use our divide rules rather than our multiply rules. So we're going to divide 1.2 divided by 7.5. Notice I put that top number in first, and that gave me 0.16. Copy the base. Now, normally I would go down to the bottom and do them down here because there's more down here. But in scientific notation, I have to stay on the top. So I'm going to write this out so you can see what I'm doing. So -8 minus 3, because remember when they have like bases and I'm dividing, I have to subtract. So 0.16 times 10 to the -11. But this is too small, so I move it over 1 and make it 1.6 times 10 to the -1, one spot and smaller than the range, so that's why I made it negative, times 10 to the -11. So my final answer would be 1.6 times 10 to the -12 because I just added those. All right, I have one more, this last one. Go ahead and push pause and give this a try and see if you can come up with it on your own. And when you're ready, come back to me and I'm going to go ahead and do it. So 2.75 divided by 5 is 0.55. Copy the base. So I write -9 minus, and then I need the -2 up there. So that's 0.55 times 10. That would be a -7. And you could use your calculator on that if you wanted. So this is too small. It's smaller than the range. So I change it to 5.5. It's negative because it was too small, and it's 1 because I jumped over once. And then I just need to combine these two. So 5.5 times 10 to the -8 is my final answer. All right, we have a worksheet to do. I think there's 12 problems on it. So if you have any questions, let me know.